can one of the besties explain the power of quantum computing and how it can change industries like medical, pharmaceuticals, any good companies that are leaders in quantum computing?
I'll take a cut at this one. So, and the reason I pointed it out is because a lot of people do talk about quantum computing potentially being a path to cracking the hashing functions in Bitcoin mining and potentially overwhelming the network and effectively counterfeiting the Bitcoin ledger. And so, technically, a quantum computer is a computer that uses qubits, which is a storage of a quantum state versus a storage of a binary state, which is a binary digit, which is called a bit in traditional computing, classical computing.
A 1 and a 0.
A 1 and a 0. And a quantum or qubit, a quantum state, can be a much more dynamic function. And so it's a state that is it's very analog and very representative of kind of a much more kind of broader condition than just a 1 or a 0.
It could be a 1, a 0, or neither. Right? It can have neither state as well.
Think about it as a wave function. And so a qubit can only exist in a piece of matter where you can hold the fidelity of a quantum state, meaning it can't be disturbed. So right now, all quantum computing gets disturbed. It all has some error-prone context to it. And so in order to use qubits to do calculations, we use what's called quantum error correction on those qubits. And so we adjust the qubits and the output to try and resolve it. A qubit with no errors is called a logical qubit. And a logical qubit has not been built. It would require very, very, very low error rates. And there's a bunch of and there's a bunch of theories around when this is going to happen. When are we going to have truly logical qubits? When does the error rate get low enough that these qubits are truly kind of useful? Now, there is an estimate that the number of logical qubits needed to crack RSA 2048, which is the big kind of encryption standard, which could kind of break the whole cryptocurrency model, it would require about 4,011 logical qubits. Today, the largest quantum computer has about 100 qubits that are very noisy, and so it's less than one logical qubit. And so we would need somewhere between 100,000 and a million qubit computer to be able to have enough quantum supremacy to be able to tackle a project like cracking RSA 2048. And by some estimates, and some people have tried to estimate when this would happen, and the estimate currently by some researchers is that there's a less than 5% chance this happens before the year 2040. So we're talking somewhere between the year 2040 and the 2060 when we get a quantum computer that has enough logical qubits to be able to crack a problem like RSA 2048 and basically make all crypto fail. And between now and then, a lot of people are working on quantum cryptography, which is new methods of encryption that are kind of built for the quantum era and the quantum frontier. Now, what's more interesting is that over the next 10 years or so, the current super noisy, super low fidelity quantum computers can be used to simulate quantum states, which is the condition of atoms and molecules, and use that to do better modeling of physiochemical properties of material. That's where the breakthroughs will happen in the next decade. So all the hard discrete problems that we kind of theorize about cryptography and other stuff, that's decades away. This decade, we are already going to start to see quantum computers have breakthroughs in how atoms and molecules interact with each other. For example, finding proteins that can do a better job of having an enzymatic reaction in the physical world, where we can now potentially pull nitrogen out of the atmosphere to make fertilizer or drugs or specific protein targets that can go in the human body and have specific functions by modeling what we can't do with traditional computers today, modeling the quantum properties of those molecules and how they interact with other molecules, and then building really cool predictive models that we can then turn into products. And that's going to be chased really hard this decade. Everyone's going to be going after it. And we already have enough compute power. I don't think that there's any leader in quantum computing today. These are all still science experiments. They're all breadboards. IBM, Google, Microsoft, a bunch of research labs, a bunch of startups are all kind of basically doing the same thing with different types of qubit technology, but they all have very high errors. They all have very low qubit computers. And so it's still unresolved who's going to come out with something useful.
Two companies to follow are D-Wave, which was started in 99. So just to give you an idea of how long people have been working on it. So it's a 22-year-old company. I know Steve Jurvetson's been backing it for now in its third decade. And then Ionic, is that the other one? IONQ?
I think like
SPAC'd, right?
Quantum computing is like fusion.
Yes.
It's like a technical problem that has attracted people who've had more money than common sense. And it's just basically a way to burn an enormous amount of money over 20 or 30 years. And the problem with that is that you start to build in technical cruft. Anything that is still in R&D phase 20 years in needs to get scrapped and rebuilt from scratch because everything has changed, including the people. Even the 20-year-olds that started are now in their 40s and have kids and just have a completely different risk management.
It's a great point, Chamath.
And
really true.
And so like you got to just scrap these projects and start all over again because the problem is you need somebody completely naive to look at this problem in 2021 and say, well, okay, how are we actually going to really solve like the coherence problem? I don't know. How are we going to build a gate array? I don't know. And you have these very formulaic ways that we knew based on what technologies were available in 99 or 2000 to start with. And I think that's probably part of why we've framed the problem as largely sort of this thing of like, okay, maybe there's like a integer factorization thing you can do. And it's like, I don't know. I'm deeply skeptical.
Yeah. Well, I agree. And
by the way, this is why, sorry, can I just say one last thing? This is why AlphaFold beat quantum computers to the solution of protein folding. And the reason was they were just like, we'll just take a different run at it. Completely different people, a completely different technical framework and modality, and a completely different risk profile and age as well.
A company to keep an eye on in the fusion space, Commonwealth Fusion Systems. I just had Bob Mumgard.
Wait, Zach, what were you going to say?
What I was going to say is that the main thing I was thinking about while you were giving that dissertation on qubits or God knows what is that I would never invest in this. That's all I was thinking is I would never invest in this.
Yes, you're focused on SaaS and marketplace.
It's exactly what Chamath said.
Definitely 7 queens and 8 kings and 5 aces in the deck.
Look, these are science fair experiments, with indefinite time frames. This is basic R&D that should be done at universities. These concepts are not ready for commercialization.
Exactly what they said about AI, and then now it's infected every company. So
no, that's not true, Jason. Because there was
they were saying this about AI 10 years ago. DeepMind couldn't get funded.
I completely disagree with you.
DeepMind could not get funded in the beginning.
No, completely disagree with you because there was a practical commercial revenue generating opportunity for AI and machine learning literally from the start of computing. It took several iterations. You're saying
there's no use case for fusion energy? I mean, of course there is.
No, I'm not saying that.
No, but it's still at the basic R&D stage.
It's still basic R&D.
I'll partially agree with you, Jason, in the sense that I was not investing in AI 10 years ago because I thought at that stage it was still in the realm of science fiction. But we just announced 2 deals in the last 2 days, 2 seed deals, Viable, which is basically an AI voice of the customer. It slurps in all of your customer feedback and then gives you answers. And then the other one is
the copywriting one.
It's a copywriting AI called Copy.ai, which literally writes your site.
Trying to get a slice right now.
Yeah, we might give you a slice, Jason. Stop being so skeptical. But
I'm all in.
Yeah, but here's what's changed. Right? Is these are seed companies with just a handful of employees. They're built on GPT-3. So you had this like basic R&D done. It creates this platform called GPT-3.
It's like now AWS, right?
Yeah, you can now build companies on top of that. So, I mean, look, what I invest in are the commercialization of new technology waves. Those technology waves happen because of deeper R&D.
What do you think about VR and AR? Because there's the same conversation with VR and AR. Like, are these worthy investments or not?
I think Sachs's point is such a good one because what he's saying is what I think has happened over the last century. The government, the best role the government can provide is to take on that technology risk, that large capital intense technology risk. This was the case with the Manhattan Project, and we got nuclear energy out of it. It was the case with Apollo Project. We have the space industry as a result now. And it's what happened with the Human Genome Project. And now we have an incredible genomics revolution and ARPANET. And that extensive early stage de-risking requires an incredible amount of capital that's very low returning. It doesn't return anything. It's what Sachs is saying is later is the commercialization.